There we go. So first we have the graph of the tangent function. So the properties of tangent is the domain is all real numbers except integer multiples of pi over 2. The range of tangent is all real numbers. Tangent is an odd function, which means it reflects over the origin. Tangent has a period of pi. Tangent has x-intercepts at multiples of pi, and vertical asymptotes occur at odd integer multiples of pi over 2. Now the question is, what coordinates do we pick for tangent? How do we graph tangent nicely? So I have the unit circle here for us so we can reference it. And remember, tangent puts sine over cosine, or if you're looking at coordinates, tangent puts y over x. So if we look at the first coordinate here at 0, tangent at 0, we'll put 0 over 1, which means, is that going to be a nice coordinate to graph?
Yes.
Yes. Okay. And then we go up to pi over 6. Do we even want to deal with graphing 1/2 over the square root of 3 over 2?
Not me.
I don't.
No. Then we look at pi over 4. What is square root of 2 over 2 over itself?
1.
1. So that'll be 1. That'll give us 0. Do we want to deal with pi over 3?
Nah.
No. What about pi over 2? That puts 1 over 0. What's that going to give us?
Undefined.
Undefined. And then do we want to deal with 2 pi over 3?
No.
Nah.
No. Do we want to deal with 3 pi over 4?
Yes.
Yes, that'll give us
-1.
-1. We don't want to deal with pi over 6. And what about pi? Pi will give us what value?
0.
0. Hey, look at that. So this means that we are going to choose, the x values we're going to choose for tangent are going to be from 0 to pi. And we'll even do the negative revolution of negative pi to 0. So when I fill out my XY chart over here, we're going to start at negative pi. And then we're going to go negative 3 pi over 4. And then negative pi over 2, negative pi over 4, and 0. And then just repeat. Pi over 4, pi over 2, 3 pi over 4, and pi. And just like we said over here, tangent at pi, no matter if it's negative pi, tangent at pi will be 0. Tangent at negative 3 pi over 4, well, before we get into that, remember that tangent is odd. So you can rewrite tangent of negative 3 pi over 4 as the negative tangent of 3 pi over 4. Well, what is the tangent at 3 pi over 4?
1.
Well, it's -1, but what's waiting on the outside?
The negative again, so it's going to be
The
positive.
negative, so it'll be 1. So that means you'll get 1 undefined, -1, 0, 1, undefined, -1, and 0. These are the parent function coordinates we will choose for tangent only because they graph nicely. All right. So let's go ahead and plot them below. So I have negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, and pi. Highest we go is 1, lowest we go is -1. Okay. And then go ahead and plot my points. So I have, first off, I have vertical asymptotes at my pi over 2s. So that's what I'm going to graph first. Okay, so there's my vertical asymptotes. And then I'm going to plot my points. So negative pi, I'm at 0. Negative 3 pi over 4, I'm at 1. Negative pi over 4, I'm at negative 1, 0, 1. And then 3 pi over 4, I'm at negative 1, and then there's 0. Okay, so I'm going to graph the middle piece first, just to show you how tangent looks. Tangent will follow your vertical asymptote down, and then it'll come up, curve around, and follow your vertical asymptote up. And then we can do the same. And there is the graph of tangent. Okay. So for the, again, I'm just going to rewrite it down here. The domain for tangent. Wait, come on. The domain for tangent, it exists everywhere except at odd multiples of pi over 2. So for our domain, we can say x does not equal pi over 2 k, or k pi over 2, where k is an odd integer. And then the range for tangent is just all real numbers. Okay, there is the graph of tangent. Any questions on that?
So on the k part, why is it just odd integers of pi over 2, whatever? Like,
Because if you look at the properties of tangent, right, we say that the domain is all real numbers except, well, let's just say odd integer multiples of pi over 2, because the next vertical asymptote is going to be at 3 pi over 2. And then the next after that will be at 5 pi over 2, 7 pi over 2, 9 pi over 2. So vertical asymptotes for tangent happen at odd multiples of pi over 2. Because if you look at your unit circle here, tangent would put negative 1 over 0, which also makes it what?
undefined?
Undefined. And is 3 pi over 2 odd?
Yes.
Yeah.
Right? Right? Because look, 3 pi over 2 could be written as pi over 2 times 3, where 3 is what?
K.
3 is k, which is an odd integer. Good? And then if you
Yeah, I
did
think I see it now.
and then if you did another revolution, that would be considered 5 pi over 2, which is also odd. All right, good with that?
Yeah, basically it's just whatever the coefficient number in front of pi is, as long as it can't be even, it has to be odd.
Exactly. If it's even, it actually becomes an x-intercept. Okay. Now, so that's the graph of tangent. Now let's look at the graph of cotangent. All right. Well, cotangent is the reciprocal function of tangent. So cotangent would put x over y. Well, guess what? We're going to choose the same exact coordinates. Let's look at it. If we choose 0, cotangent puts x over y, which means it puts 1 over 0, which will give us what?
Undefined.
Undefined. Do we care about pi over 6?
No.
No, we go on to pi over 4. what would the cotangent of pi over 4 be?
1.
Again.
1. And then we go to pi over 2. We don't care about pi over 3. And what would the cotangent of pi over 2 be?
0.
0. Don't care about 2 pi over 3. So we go to 3 pi over 4, and the cotangent of 3 pi over 4 would be
-1.
-1. And then we come to pi, where we're going to get what again?
Undefined.
Undefined. Good. Ugly arrows. Okay, so cotangent and tangent share the same x values because those are the ones that graph the nicest. We can graph pi over 6 and pi over 3, but that's only if you like graphing ugly things. Okay, so same setup here, guys. Negative pi to pi. So negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, and pi. And we said that this will give us undefined. This will give me 1. And then this will give me 0, -1, undefined, 1, 0, -1, undefined. Okay, now plot your points. Negative pi, 3 pi over 4, pi over 2, pi over 4 and 0, pi over 4, pi over 2, 3 pi over 4, and pi. Highest we go is 1, lowest we go is -1. And this time we have vertical asymptotes at integer multiples of pi. So I'll have a vertical asymptote here at 0 and at pi. Okay, and then we can plot the other points. Negative 3 pi over 4, I'm at 1, 0, -1, 1, 0, -1. And cotangent looks like this. You follow your vertical asymptote down, connect your points, and follow it back down. Same thing here. Come from infinity, connect, connect, and follow down. Okay. So properties of cotangent, domains all real numbers except integer multiples of pi. Okay. So to write that, we would say the domain is x cannot equal pi k, where k is any integer. Okay, and the range is all real numbers. That's written up there. Cotangent is odd. It reflects across the origin, and then it repeats itself every pi. And the intercepts are odd multiples of pi over 2, and you have vertical asymptotes at integer multiples of pi. Okay, any questions on cotangent?
So how do you, when you originally start the graph, how do you know it starts like way up positive and it goes down to negative?
So, I mean, that's what it would show if we graph the other points. But yeah, so if you're stuck in between those asymptotes, That means you're following this one on the left and you're finishing off by following the one on the right. So it goes up and to the left, down and to the right. Because it even goes by your y values here. It goes positive to negative. So you should start up and finish out to the right.
Oh, okay, that last part makes sense.
There you go. All right. What else? Any other questions on this? All right, then. That was cotangent. Next is the cosecant function. The properties of cosecant is that the domain is all real numbers except integer multiples of pi. The range of cosecant is all y values greater than or equal to 1 and all y values less than or equal to a -1. Cosecant is odd. It reflects across the origin. It repeats itself every 2 pi. There are no x-intercepts, and you have vertical asymptotes at integer multiples of pi. Okay, so cosecant is the reciprocal of the sine function. So cosecant is the reciprocal of the sine function. So let's start at 0. Remember that cosecant will take the y value and reciprocate it. Is there a reciprocal to 0?
No.
So that means it will be
Undefined.
undefined. Okay. And then let's look at pi over 6. Look at the y value and reciprocate it. Do we want to graph that number?
Yeah.
Yes.
What's it going to be?
2.
2. Do we want to reciprocate square root of 2 over 2?
I don't.
No. Do we want to reciprocate square root of 3 over 2?
No, still sounds pretty bad.
No. So we leave pi over 4 and we leave pi over 3 alone. And then we come to pi over 2. What is the reciprocal of 1?
Just 1.
1.
Just 1. And then we come to 2 pi over 3. Do we want to reciprocate that?
Nope.
No, sir.
No. Do we want to reciprocate square root of 2 over 2?
Mm-mm.
No. Do we want to reciprocate 1/2?
Yes.
Yes. So this means that for 5 pi over 6, we're going to get 2. And then we come to pi. And what's the reciprocal of 0?
Undefined.
Undefined.
Undefined. There you go. These are the coordinates we're going to use for cosecant. And we're going to do the negative values as well. So this is going to look like, we're going to start at negative pi. And then we go negative 5 pi over 6, negative pi over 2, negative pi over 6, 0, and then repeat. Pi over 6, pi over 2, 5 pi over 6, and pi. Okay. Now, looking at this unit circle, at integer multiples of pi, we'll have vertical asymptotes. So this will be undefined. And then cosecant of negative 5 pi over 6. Well, we saw that cosecant of 5 pi over 6 was 2. So this means cosecant of negative 5 pi over 6 is going to be what?
-2.
-2. -2, and then this will be -1, and then back to -2. And then we are undefined, and then we'll be at 2, 1, 2, undefined. All good?
Yes.
And let's go
And
ahead.
it's only cosine secant where it's it's gonna just make it even regardless, right?
What's that? Oh yeah, it's only cosine and secant that are even, right? So if I were to write one of these out, if I said cosecant of negative 5 pi over 6, this would become negative cosecant of 5 pi over 6, which means you'd have the negative and the 2, which gives us that negative 2. Okay. Label. Negative pi. Negative 5 pi over 6. Negative pi over 2. Negative pi over 6. 0. Pi over 6. Pi over 2. 5 pi over 6. And pi. Highest we go is 2. And lowest we go is negative 2. Okay. I have vertical asymptotes at pi, 0, and pi. Negative pi, 0, and pi. Okay. Now here are my coordinates. At negative 5 pi over 6, we're at negative 2, and then negative 1, and then negative 2. I'm like way off, but it's okay. And then at pi over 6, I'm at 2, 1, 2. Okay. Well, here is what cosecant looks like. Starting on the left side, you follow those asymptotes up and connect your points and follow it back down. And then follow your asymptote up, connect your points, and follow it back up. And that is what cosecant looks like. Okay, so we see our domain that it's all reals except for integer multiples of pi. So for my domain, we say x can't equal pi k, where k is any integer. And then your range, it starts at negative infinity and stops at negative 1 included, and then begins at 1 and head towards infinity. Okay. Any questions on cosecant? Everybody good?
Yep.
Okay. Well, there is one cool thing about the graph of cosecant. So cosecant is the reciprocal of the sine function. So the sine function actually fits nice and neat in between the graphs of cosecant. That's the sine function. Pretty cool, huh? You're like, yeah, that's cool. All right.
Yeah. woohoo.
Yeah, that's the
I can't
coolest
contain
thing.
my excitement.
I know.
Make a
Just-
t-shirt with that on there.
Just crazy. You should. I'll make one. All right.
On,
So that's cosecant. What's up?
on my math lab, so for that domain, is it going to ask us the exact thing like x can I equal pi k?
Yeah, I think it's gonna have you type it in like that. It's either gonna be pi n or pi k. It might be the fancier representation though. So it could be fancy brace for all x such that x can't equal pi k. But I think it'll have the definition for k for you, like where k is any integer or k is an odd integer. But it should have it. It should have this part set up and that part set up. You just have to fill in the blank. Okay, last one. Graph of secant. Remember, secant is the reciprocal of the cosine function. So secant x is the same as 1 over the cosine of x. So that means you'll look at your x coordinates and reciprocate those. So let's start at 0. What is the reciprocal of 1?
1.
1. Do we want to deal with pi over 6?
Nah.
Do we want to deal with pi over 4?
Nah.
Do we want to deal with pi over 3?
Bingo.
What will that give us?
2.
2. And then we come to pi over 2. And what's the reciprocal of 0?
Undefined.
Then we'll come to 2 pi over 3. And we'll get
-2.
-2. Skip, come to pi. And what's the reciprocal of -1?
-1.
-1. There we go. These are the coordinates we will choose for secant. Okay. So starting negative pi, -2 pi over 3, -pi over 2, -pi over 3 and 0, and then pi over 3, pi over 2, 2 pi over 3, and pi. Okay. And remember that secant is even. So the secant of negative pi just becomes the secant of pi, which will still give me -1, and then -2, and then we'll be undefined, and then we'll be at 2, 1, 2, undefined, and then -2, -1. All right, there's our coordinates for secant. So let's go ahead and plot them. -pi, -2 pi over 3, -pi over 2, -pi over 3, 2 pi over 3, and pi. Okay, so we have our vertical asymptotes at pi over 2 and -pi over 2. And now we can plot our points. So I have -pi, actually, whoops. We go up to 2 and then down to 2. And then at -pi, we're at -1. And then -2. And then I'm at 2, 1, 2. And then again back at -2 and -1. And here is what secant looks like. I'll start by drawing the middle one. Come down, connect your points. And then it'll be the same thing here. Come down, 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 down. There we go. That is the graph of secant. Properties, domain is all real numbers except odd multiples of pi over 2. So to put that in writing, your domain is x can't equal pi over 2k, where k is odd. And then your range is just like cosecant. You'll start at negative infinity, stop at -1, start at 1, head towards infinity. It's an even function, which means it's symmetric across the y-axis. It repeats itself every 2 pi. There are no x-intercepts, and we have vertical asymptotes at pi over 2. Yeehaw. That is the graph of secant. Any questions on that?
Just to recap, like on when you skip pi over 6 and pi over 4, it's because we're looking at like cosecant, the 1 over 2. It's just easier to graph, right?
Exactly. Like I said, we could graph them like, let's say we chose pi over 6. That means you're only looking at the x coordinate though, right? So
Mhm.
you would have to flip that square root of 3 over 2, which means you would be graphing
2 squared 3 over 3.
3. Exactly.
Hmm.
Which is already somewhere up here.
Hmm.
Yeah.
Okay. Makes sense.
So we just skip the ugliness and go for the ones that give us nicer outputs. And just like cosecant, since secant is the reciprocal function of cosine, this means that cosine fits nicely in between these functions. Yeehaw. All right. And that is the remaining 4 trig functions. So we've graphed sine, cosine, and now we've graphed tangent, cotangent, cosecant, and secant. And these are the perfect values to pick when graphing these 4 functions. So in case you have any transformations, then you can definitely use these pairing functions. And you can also still use key points on these. Okay. Well, that's it. We're done.